All right, for an example from section 8.5, let's look at number 15 from section 8.5. In this section, we're actually comparing two populations, okay? So this is going to depend on whether we know the population standard deviation or not, just like with one samples, on whether we use a two-sample z-test or a two-sample t-test. So in this problem, it says REM, rapid eye movement sleep, is sleep during which most dreams occur. Each night a person has both REM and non-REM sleep. However, it is thought that children have more REM sleep than adults. Assume that REM sleep time is normally distributed for both children and adults. A random sample of 10 children, 9 years old, showed that they had an average REM sleep of 2.8 hours per night. From previous studies, it is known that, and this is key here, sigma 1, that's our population standard deviation, is 0.5 hours. Another random sample of 10 adults showed that they had an average REM sleep of X bar 2, which is 2.1 hours per night. Previous studies showed that the population standard deviation for the adults was 0.7 hours. Do these data indicate that on average children tend to have more REM sleep than adults? So based on this problem, I'm going to write down what I know. For my sample of children, remember that was my first sample, N1 was equal to 10. And in the problem it told us X bar 1 was equal to 2.8, and it said the population standard deviation was 0.5. Now this problem in the book tells you that this is sigma, okay, but you need to know the difference between whether you have sigma or S, just like we did with one samples. And then for adults, which was our second sample, our N2 was equal to 10, our X bar 2 was 2.1, and our sigma 2 was 0.7. Okay, now the question is, do these data indicate that on average children have more REM sleep than adults? So we want to know if children is more than adults. So you want to set it up this way and determine your inequality sign based on the question. Okay, so it doesn't always mean more than means greater than. We want to know if children are more than adults. It could have said, do the adults have more than the children? And this would have been a less than. So be very careful on how you set that up. And then that will be the alternative in step 1 when we set up the null and alternative hypothesis for this problem. Okay, because we're dealing with two samples, we assume in the null that they're equal, and we're always going to assume they're equal in the null. And then the alternative is what we're trying to find enough statistical evidence to prove, which is this. We're testing if children have more than adults. So this would be mu1 is greater than mu2. Make sense? Okay, then in step 2, just like we had done before, we do our test statistic. So we're going to go to our calculator, and we're going to go stat over to tests. And we're going to go to two sample. Now, are we going to go to two sample z-test or two sample t-test? Well, we know that by looking at the information we're given. If we know the population standard deviations, we go to the two sample z-test. If we don't know them, we're going to use a t-test. Now, remember, as your sample size goes above 30, the t-test gets very, very close to the z-test. You can still use the t-test, but it will eventually be the z-test. Okay, two sample z-test. And if you have questions about that, you can ask me. We're going to pick stats because we don't have the data. If you had the data, like in problems 19 and 20, 23, 25, you would pick data. Okay, so sigma 1's 0.5, sigma 2's 0.7, X bar 1's 2.8, N1 is 10, X bar 2 is 2.1, N2 is 10. What are we testing? The alternative here is greater than. And we're going to calculate. Okay, so remember this is going to give us our test statistic. So in this problem, it had told us use a 1% significance level, so we know that alpha is equal to 0.01. In WebAssign, it does ask you for that level of significance. Our test statistic is Z equals 2.57. Okay, so in step 3, when I do my critical region, I need to determine, is this a right-tailed, left-tailed, or two-tailed? Based on the alternative, remember we're looking at the alternative, it's pointing to the right, it's a right-tailed test. So I need to look up my critical value here. So I go to my standard normal table. It's a right-tailed test. Oh, I kind of got this off the page. Whoops, sorry about that. Alpha's 0.01, so it looks like 2.33. So my critical value is 2.33. So when I draw in my test statistic, remember the center is 0. Does 2.7 fall to the left of this or to the right? It's to the right of 2.33, just by a little bit. Remember, I always just put my test statistic up above here. Because what I'm looking for is, does this test statistic fall in the rejection region or the non-rejection region? Agreed, it falls in the rejection region, so my decision here would be reject H naught. Let me write that over here. My fourth step would be, I'm going to reject H naught if my p-value is less than alpha. So the question is, whoops, sorry, my alpha's kind of funky. And I go back and I look at my calculator. My p-value here, remember, if it says e to the negative something, yes, WebAssign will accept it, but I won't. You have to put it in number format, not scientific notation. So 0.0050, and I always take it out 4 decimal places, 0050. The question is that less than alpha of 0.01? Yes, it is. Remember, just add the zeros, compare the numbers. Is 50 less than 100? Yep. So the answer is yes. So therefore, I reject H naught. Okay, these two should match, remember. Okay? So had it fallen in the non-rejection region, I would have said do not reject H naught. And in WebAssign or in the back of the book, they also call that fail to reject. I like to say do not reject H naught because remember when you do your interpretation, we say at the 1% level of significance, we do or do not have enough statistical evidence. And that's where, instead of saying fail to reject, if you would have said do not reject, that's where you would have said we do not have enough statistical evidence. Okay, here we do, because we didn't say do not, right? So we do have enough statistical evidence to conclude that, and remember, I think it's easier to go back to the book here, where our problem asks us, do we have enough evidence? Oops, sorry. Let me get to the page here. Do the data indicate that, see that word that right there? On average, children tend to have more REM sleep than adults. That's what I'm concluding. I'm following that word that. So we do have enough evidence to conclude that, on average, children tend to have more REM sleep than adults. And that's the easiest way to put it back in the context of the problem.